And I should note too, these are all things that archaeologists always did, but GIS gave us the tools and geospatial technologies gave us the tools to really ramp them up and do them better, more quickly, and with, I think, more efficient results. So I'm just going to talk a little bit about detection, reconnaissance, and recovery in the context of an archaeological field school that we run out of the Department of Anthropology here at UNH. It is called the Belize River East Archaeological Project, and we have a graduate here, Steve, who will follow me up after. And so this BREA project, we call it, we take students down to Belize every J-term and summer term, and we teach them archaeological mapping and survey techniques as well as excavation. So that's where these examples come from. In GIS and geospatial techniques have really enhanced our ability to detect archaeological sites, both in open areas, recently cleared areas, as well as in forested areas. This is a small portion of our project research area, which we had spent about 4 years mapping in traditional ways with the total station with handheld GPS. We were lucky enough a couple years ago to have a friend of ours come down and bring his unmanned aerial vehicle with him, or drone, and he flew over this area, which again, we had been working diligently on the ground to find and record the remains of human settlements. And in a matter of 3 days, Mark was able to turn around, taking thousands and thousands of these very detailed photographs. He was able to stitch them together and turn around this really wonderful topographic map that gave us far more detail, right? Undulations of the topography, and also indicated little areas that could potentially be anthropogenic mounds, mounds created by the ancient Maya, that we hadn't yet gone out and actually ground truth. Again, we had spent something like 3 to 4 years and had only uncovered a fraction of the mounds that he was able to reveal with this remote sensing type of technology. So again, this has been very important in terms of helping us. At another important site, a big site in Belize known as Caracol, similar types of geospatial technologies have helped reveal what is there. And in this case, Caracol is very heavily forested jungle. And so through LiDAR and satellite imagery, this is the old map that was developed based on 30 plus years of archaeological excavation and survey. The LiDAR imagery, right, is far more detailed, gave us far greater resolution in terms of the actual topography of the landscape, other features, human-made features that we had not seen beforehand. So it really opened our eyes in many ways. I was going to put in a slide to talk about how this type of geospatial technology is also being used in a heritage management framework. So in order to sort of collect and manage what's happening to archaeological sites in the Near East today, especially places like Syria and Iraq. I didn't have time to put that slide in, but I thought I would mention it anyhow. Here you can see a composite 3D image, again, of that Caracol landscape, far more detailed than we had ever been able to amass before then. We also use geospatial technologies for reconnaissance. So once we find, oops, am I done already?
Just about.
Just about, okay, all right. So we use it for reconnaissance as well. I'll skip through some of this. One thing that we're always interested in is how intact our archaeological sites are. I didn't even see the sign, sorry.
That's okay.
How intact our archaeological sites are. And so through surface collection and survey and pairing that with GIS technologies, we can actually start to see how much drag has occurred in disturbed areas. So again, that has been something that very much plays into our abilities to interpret what was actually going on in the past. So I didn't get anywhere near to the end there, but we do lots of least cost path analyses with interesting results, and I will just skip ahead to my last slide. So, any questions?